Hi and welcome to this section where we are going to look at properties of forward difference operators. The first property we would like to look at is that if we consider a constant function f of x equal to k, then the forward difference of first forward difference of f of x, which by definition we said is f of x plus h minus f of x, is going to be equal to k because it's a constant function. F of x plus h is k and f of x is also k, and this gives us 0. The second is that we would like to look at if we consider two functions f of x and g of x, then the first forward difference of their sum is the first forward difference of the sum of the individual functions. In other words, this is like a linear operator. Okay, it works like a linear operator. 3, if we have very similar to 2, is that the first forward difference of the function a f of x plus b g of x, where a and b are constants, okay, then this is given as a, the first forward difference of f of x, plus b, first forward difference of g of x. Okay, and then 4, if we have a product, then the first forward difference of f of x times g of x, okay, is given as f of x plus h times the first forward difference of g of x, then plus g of x times the first forward difference of f of x. Please note that the proofs for these are found in the text, and you can really follow them from the definitions of the first forward difference. The fifth one says that the first forward difference of a quotient f of x over g of x is given as g of x times the first forward difference of f of x minus f of x times the first forward difference of g of x divided by g of x plus h times g of x. Okay, perhaps we could look at the proof of this one here. We're just looking at the proof of selected few. By definition, we know that if we have this quotient here, then its first forward difference is going to be f of x plus h divided by g of x plus h minus f of x divided by g of x. Okay, and then which we can simply simplify using our algebra, and we know the LCM here is g of x plus h times that. Then what do we have here? We have f of x plus h times g of x minus f of x times g of x plus h, and yes, that is it. Then in the next step we shall just introduce the simple trick. Okay, we write that, and then we subtract f of x, g of x, and add it. Okay, we subtract and add. In other words, we haven't done anything here. We are just introducing this just to arrive at some desired result. Okay, so we have that, and then everything was over g of x plus h times g of x. Okay, Then next we are going to combine this and that, and then we combine this and that. So now if we combine the first two terms, we factor out g of x, so we have g of x, and then we have f of x plus h minus f of x, and then if we put a plus outside here, in the next two terms we can factor out f of x, and then this will be g of oh, this is a negative. Okay, so perhaps we put the negative outside here, so we have f of x, and then we have g of x plus h. This is the negative term, and then since this term is the positive, we shall have minus what have we factored out? We have factored out f of x, so okay, so here we have g of x. Okay, and then this this we divide by g of x plus h times g of x. Okay, and then next we know by definition that this is the fast forward difference of f of x, and then times f of x, and then this is the fast forward difference of g of x. Okay, then everything we divide by g of x plus h minus g of x, and that completes our proof. So like you can see, you can also follow the rest in the book. They are the proofs all follow from the definitions. Okay, right, so some more useful results here. Let us start some more useful results by just having this simple illustration, this tabular illustration, which we did last time, but for purposes of just reminding ourselves, we shall just do it here, because we are going to quote some of the results from here. Okay, not necessarily, but maybe it will just help us just to refresh our memory on this. Okay, so we have a table here, and then we would like to start maybe here we have our values of x, and then here we have our values of f of x, and then here we have our fast forward difference. Please note that we are using f interchangeably. We can use f of x, y equals to f of x, so when someone writes f naught or y naught, they simply mean more or less the same thing. Okay, so this is the second forward difference, the third forward difference, the fourth forward difference, the fifth and the sixth forward difference. Okay, so let this be x naught, and maybe we have here x1, let us have here x2, let us have here x3, let us have here x4, and so on and so on. So this is the value of f at x naught, which is f1, the value of f at x1, which is f1, the value of f at x2, which is f2, then the value of f at x3, and the value of f at x4. And then this one here, this is the fast forward difference at f naught, which by definition we said is f1 minus f2, f1 minus f2. Okay, and then this is the fast forward difference at f1, which is simply f2 minus f1, and then this is the fast forward difference at f2, which is f3 minus f2, and so on and so on. And this is the fast forward difference at f3, which is f4 minus f3. Then next here we would have the second forward difference at f naught, which is given by the fast forward difference at f1 minus the fast forward difference at f naught. Of course, if you need to simplify further, you can substitute the fast forward difference. You can substitute for the fast forward difference here by putting in f3 minus f1, or here the fast forward difference at f0 by putting in f1 minus f2. Okay, sorry, this is the fast forward difference at f1. This is f2 minus f1. Okay, I hope I didn't say f3. This is f2. So you can follow similarly here. What would this be? The second forward difference at f1, which would be given by the fast forward difference at f2 minus the fast forward difference at f1. Then the second forward difference at f2, which would be given by the fast forward difference at f3 minus the fast forward difference at f2, and so on. So the third forward difference here, the third forward difference at f0 would be the second forward difference at f1 minus the second forward difference at f0, and so on. So you can follow the logic in the table and fill in that. Okay, now let us try to write down a few more things. For example, we can write and say that we can say that the second forward difference, okay, at f0, because we have seen that it is simply the fast forward difference at f1 minus the fast forward difference at f0. But we know that the fast forward difference at f1 is f2 minus f1, then minus the fast forward difference at f0 is f1 minus f2. So we can open the brackets, and then we have f2 minus f1 minus f1 plus f2, for which we now have did I say f2? Sorry, this is f1 minus f0. Okay, yes, so we have f2 minus 2 f1 plus f0, right? Yeah, so you can follow also the procedure in the text and get the result for the third forward difference at f0. So the third forward difference at f0 we know is going to be the second forward difference at f1 minus the second forward difference at f0. Okay, then the second forward difference at f0, this one here, we have already derived it, so we shall just be substituting. And then you can also derive this one in a similar fashion and follow with what is in the text. Alright, if you have any difficulty, you can please put it in the comment section. So let us write a few results here which we are going to use later on. We know the fast forward difference at f0 is f1 minus f0, and we can make f1 the subject here, and making f1 the subject, we know that it is going to be equal to f0 plus the fast forward difference at f0. Then 2, the fast forward difference at f1 we know is f2 by definition minus f1, and then we can make f2 the subject here and write it as f1 plus the fast forward difference at f1. Okay, the fast forward difference at f2 is f3 minus f2, and then we can make f3 the subject here and write it as f2 plus the fast forward difference at f2. Okay, and so on and so on. Now we can write the second forward difference at f0, okay, as the fast forward difference at f1 minus the fast forward difference at f0, and then we can make the fast forward difference at f1 the subject as the fast forward difference at f0 plus the second forward difference at f0. In a similar way, we say that the second forward difference at f1 is given as the fast forward difference at f2 minus the fast forward difference at f1, and then we can make the fast forward difference at f2 the subject, which is equal to the fast forward difference at f1 plus the second forward difference at f1, and so on and so on. Okay, now we would like to write f2. Okay, we would like to write no, not f2 now. Yes, okay, we would like to write f2 as f0. We claim that we can write f2 as f0 plus the fast forward difference of f0 plus the fast forward difference at f0 plus the second forward difference at f0. Okay, if we would like to verify this, we can just try expansions here, and then we see. Let us expand this and then we see whether on the right hand side we also get f2. So we have f0, okay, then plus fast forward difference f0 plus fast forward difference f0, and then we know that the second forward difference of f0 can be written as the fast forward difference at f1 minus the fast forward difference of f0. Okay, so here we already have this term and one of these which cancel. So now we have f0 plus the fast forward difference at f0 plus the fast forward difference at f1. Okay, plus the fast forward difference at f1. So let us try to expand this also. This is f0, fast forward difference at f1 is f1 minus f0, then the fast forward difference at f1 is f2 minus f1. Okay, so we see other terms which also cancel out here. f1, and then f0 cancels f0, and therefore we have that f2 rather equal to f2. So that means that this whole expression here, if we expand it, it reduces to f of 2. Okay, f2, not f of 2 rather, the value of f at our function x2. So that now that we have seen that this statement here is okay, we go ahead and just write it as f0 plus this, and that is twice the fast forward difference at f0, and then plus this is the second forward difference at f0. And what do we have here? This is f2. So we shall make some conclusion later on. Let us pause it for now, and now go ahead and try to write f3 also. So f3, we shall pick we shall just pick this expansion which we have here, or this expression here. f3 is f2 plus the fast forward difference. This f3 is f2 plus the fast forward difference of f2. Now let us see, do we have any substitution for f2? Yes, we have a substitution for f2. And what is f2? f1 plus the fast forward difference. So f2 is f1 plus the fast forward difference of f1, plus, do we have a substitution for the fast forward difference of f2? Yes, we do. Fast forward difference of f2 is fast forward difference f1 plus second forward difference f1. So this is fast forward difference f1 plus second forward difference f1. So this is going to be f1 plus 2 fast forward difference f1 plus second forward difference f1. So can we make some more substitutions? Yes, for f1 we can still make a substitution, which is f0 plus fast forward difference f0. So we have f0 plus fast forward difference f0 plus 2 into, what about fast forward difference f1 here? Do we have it? Yes, fast forward difference f1 is fast forward difference f0 plus second forward difference f0. This is fast forward difference f0 plus second forward difference f0. Then plus this one here, we can just write it as fast forward difference, or the fast forward difference F1. Okay, we saw that before. I hope I explained that. Okay, yes, I think I explained that when we were deriving the second forward differences. So now we can try to simplify this. We have F0, then we have the fast forward difference F0, then plus 2 fast forward difference F0, plus 2 second forward difference F0, then plus the fast forward difference of the fast forward difference of F1, which we already have here already, which is fast forward difference F0 plus second forward difference F0. Okay, so we can simplify this further, and then we say we have F0 plus this and that will give us 3 fast forward difference F0, then plus twice second forward difference F0, then plus now this and that will give us now second forward difference F0, plus this and that will give us the third forward difference at F0. So we can still simplify this, and then we say it is that plus 3 fast forward difference F0, then this and that also will give us 3 second forward difference F0 plus the third forward difference of F0, and this is F3. So this is also a result which we are going to make sense of. Okay, so let us go back here where we said we'll make use of, sense of this result as well, and try and factor out F0. If we factor out F0, we have 1 plus 2, the del operator, plus del operator squared. And I hope you can appreciate that this is just the del operator squared, and then this is F0, and then this is F2. Okay, now if we also go back, return here and do the same, we put F0 out, so we have 1 plus 3 the del operator plus 3 the del operator squared plus the del operator cubed. You should be able to appreciate that this is 1 plus the del operator to the power 3 F0, and this is F3. So when you look at these two results, and in general anyway, not just 2, but even if you get F4 and so on, only that F4 that will be very long very long series of substitutions and expansions, we should be able to okay, we deduce that f of n, in general f of n can be written as 1 plus the del operator to the power n times F0. Okay, this is to the power n. Okay, in general, this is a general result. So we can still see that even this general result, someone can use the binomial expansion and even write it in another way, and then say if you follow just the binomial expansion, then we can as well say that f of n equals to F0 plus n combination 1 del F0 plus n combination 2 del squared F0 plus and so on plus del to the power n then F0. Okay, and also which can be written in short form as the summation from I equals to 0 up to n of n combination I, and then the del operator the power I times F0. So these and many other results which you will find in the text simply follow from the definition of the forward operator. So please try out all the exercises, and in case you face any difficulty, place in the comment section, and we will help you. Okay, so see you next time, and yes. Bye bye.